All right, let's look at another example, but before we dig into it, just some warnings that the next example we're going to look at is kind of long. I would suggest take good notes and you know what, perhaps start at the top of a new sheet of paper. Where possible, I included reminder equations from previous slides, but this wasn't really always possible. Sometimes just the work, just even within a slide, took up so much space. By now you've noticed the uses of and or, which are very mathematically precise. When you see x equals plus or minus 5. Notice I even said the word or, right, between plus and minus. So plus or minus 5, that's really x equals 5 or x equals negative 5. So if you see x equals plus or minus 5 and y equals 6 and z equals 8, this is really kind of as shown in the box. And apologies for the parentheses. They look a little funky, but it's, I think, very important for clarity. If you haven't taken a class on how to write proofs, or perhaps you haven't taken a logic class in a philosophy department, then you can, really teach what you need to about the words and or using truth tables in about an hour, maybe even less. It's an optional activity. I'm not saying you have to do it, but it might be kind of helpful for understanding what's going on. Now, if you have taken a class on how to write proofs, the outline of the next problem might remind you a little bit of proof by cases. If you haven't taken such a class, don't worry. I've tried to say enough to still guide an outline of what's going on here. So let's minimize the function f of x comma y comma z equals x to the fourth plus y to the fourth plus z to the fourth, subject to x squared plus y squared plus z squared equals 1. You'll notice that there are 3 input variables instead of 2, but the methods should still work. So we'll do the process of Lagrange multipliers, compute gradient of f, gradient of g. Sorry about the typo here. This should just say 2z, not 2yz. Apologies about that. I will correct that before uploading. So we'll set the gradient of f equal to lambda times the gradient of g, set components equal, at least it's fixed by here finally. So we get a lot of equations that look really similar, right? So 4x cubed equals lambda 2x, and then basically the same equation using y's instead of x's, and then basically the same equation using z's instead of x's, and we still have the constraint up here, x squared plus y squared plus z squared equals 1. So there's 4 equations here. There's a lot to deal with. There's lots of different scenarios, or you might call them cases, and by the end we will have examined really all the possibilities. So first, let's just consider when x, y, and z are all not 0. So if x, y, z are all not 0, then we can divide by x, or we can divide by y, or we can divide by z. So we'll get lambda is equal to 2x squared. If you take the first equation to divide both sides by x. Similarly, you have lambda is equal to 2y squared, lambda is equal to 2z squared, and since these are all lambda, let's just set them all equal to each other. So 2x squared equals 2y squared equals 2z squared. Divide all 3 sides by 2. X squared equals y squared equals z squared. Now, how is that possible? Well, here's the thing. Let's actually take the fact that x squared equals y squared equals z squared. Here, really the point is x and y have to be the same, other than perhaps can be different in sign. But sorry, I'm getting a little ahead of myself here. Let's just take x squared plus y squared plus z squared equals 1 and substitute y squared and z squared away. So we'll have x squared plus x squared equals 1. In other words, 3x squared equals 1. So x equals plus or minus root 1/3. We'll write that as plus or minus 1 over root 3. And the thing is, from the fact that x squared equals y squared, y has to be the same and z has to be the same. And here's the thing. There's actually 8 points of the form plus or minus 1 over root 3, comma, plus or minus 1 over root 3, comma, plus or minus 1 over root 3. So there's really 8 points of this form, because you can take plus plus plus, or plus plus minus, or plus minus plus, or plus minus minus, and then finally 4 more where the x coordinate is negative. And if you run through any of these 8 points back into the original function f at the top, they all have the same f value, namely 3/9, which will simplify to 1/3. Okay, so that's the case when x, y, and z are all not 0, right? Notice that we didn't find the value of lambda at all. We could if we wanted to, but we actually just got x, y, and z first. This is kind of unusual because in so many other problems we've looked at so far, you get lambda and then you get x and y and so on, right? So we didn't get lambda first. We got x, y, and z first, and we didn't bother computing lambda because all we really need are x, y, and z to plug into f. Okay, note before continuing, we just considered the case when x is not equal to 0, and y is not equal to 0, and z is not equal to 0. And these were the 8 points just to spell them all out in detail. Sorry, this list looks a little messy, but either the x-coordinate is positive or negative, either the y-coordinate is positive or negative, either the z-coordinate is positive or negative. And I tried to organize this systematically, so you'll notice that in the z-coordinate, I've done plus, minus, plus, minus, plus, minus, plus, minus. In the y-coordinate, instead of alternating every other, it's alternating every two, so plus, plus, minus, minus, plus, plus, minus, minus. And then for the x-coordinate, it alternates every 4, so plus, 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 followed by minus, 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 minus. So that will systematically get all 8 points that we have, and in all of these, if you plug in any of these 8 points into f, you'll get 3/9. This value of 1/3 was found without finding lambda first, and sometimes that happens. If you're curious, we could get lambda. We just get it from lambda is equal to 2x squared. But I mean, here it is, fine. Lambda is equal to 2/3, but we actually don't need this value. Okay, let's consider the case when x equals 0, but y and z are not 0. Okay, so our 4 equations from earlier, let's see. There was one that was like lambda is equal to 2 times x squared, but then if x is 0, then the right side is 0, the left side becomes 0. And then we still have lambda equals 2y squared, lambda equals 2z squared, and then plugging in from x squared plus y squared plus z squared equals 1, since x has to equal 0, we get a thing that looks like this. So we end up with y squared equals z squared from setting the lambdas equal here, right? 2y squared equals 2z squared leads to y squared equals z squared. So then we can substitute y squared plus y squared equals 1. So 2y squared equals 1, so y is equal to plus or minus 1 over root 2. We end up getting 4 points. They're of the form 0, then comma plus or minus 1 over root 2, comma plus or minus 1 over root 2. By the way, we just looked at what happens when x equals 0 and y and z are non-zero, but look at the symmetry of the problem, right? The function is x to the 4th plus y to the 4th plus z to the 4th, and also the constraint was x squared plus y squared plus z squared equals 1. So you can swap the x's for the y's or the x's for the z's or so on and so forth. So instead you could have the middle coordinate y is 0 and x and z are non-zero, so you get 4 more points. They should be very similar in fashion. And then similarly, if z is 0 but x and y are non-zero, you get 4 more points. So 4 points and 4 points and 4 more points, a total of 12 points. All 12 of the points here, if you run them through the function, x to the 4th plus y to the 4th plus z to the 4th, you're actually going to get the f value to be 2/4, or in other words, 1/2. Okay, our first case was all 3 of x, y, and z non-zero. Our second case was one of these 3 variables is 0, the other 2 are non-zero. So now let's look at the situation when 2 of these variables are 0 and 1 isn't. So just to make it more concrete, how about x and y are 0 and z is non-zero? So then here again, just a reminder that the equations that we had, the first 2 equations are just 0 equals 0 and 0 equals 0, and then the next equation, we have, let's see, lambda is equal to 2z squared. So you can get this by dividing both sides by 2 and dividing both sides by z. Now remember, because z is non-zero, we can divide both sides by z. And then we end up with 0 squared plus z squared equals 1, because we plug in 0 for x and y. All right, so let's take a look at those 2 equations. The last one, of course, just z squared equals 1 means that z equals plus or minus 1. And then we get 2 points. So remember we said we started with x and y are both 0. So we get points of the form 0, 0, 0, comma, 0, comma, plus or minus 1. And we didn't find the value of lambda again. We could if we want, but we didn't. And then the thing is, switching the roles of the variables, if it's now, x and z are 0, then you have 0, comma, plus minus 1, comma, 0. And if you switch roles of variables again, and y and z are 0, then x is either plus 1 or minus 1. So there are 6 points here, right? So basically, 2 coordinates are 0, and the other coordinate is either a plus 1 or minus 1. So there's 6 points total of this form. They all, if you run them through the function f at the top, you're going to get f value 1. Okay, last, it seems we should consider the case when, so we've done x, y, and z are all non-zero. We've done, all 3 are non-zero. Then we've done when 2 of them are non-zero. Right, how do we word this best? We've done when all 3 are not 0. Then we've done when 2 are not 0. Then we've done when 1 not. So then it seems like that we should also look at the case, what about when all three of them are 0? Right? That seems to be the only thing that's left over. This is actually impossible because remember we had x squared plus y squared plus z squared has to equal 1. So if x, y, and z are all 0, the constraint just isn't satisfied. Okay, so we've considered all the points that we should. Points of the form you see there, plus or minus 1 over root 3 for each of the coordinates, had f value 1/3. Points where one coordinate is 0 and the other two coordinates are plus or minus 1 over root 2's, had f value 1/2. And then finally, points of the form where two of the coordinates are 0 and then the remaining coordinate is a plus 1 or a minus 1, had f value 1. So look at these f values, 1/3, 1/2, and 1. And then we will now summarize, right? So we're looking for the biggest or the smallest, you know, if we're min or maxing. So the max occurs with value 1, and it occurs at all of these points here, 0, 0, plus or minus 1, 0, plus or minus 1, comma 0, and then plus or minus 1, comma 0, 0. What about the smallest value? It's 1/3, and there are 8 places where that occurs. There are all the points where each coordinate is either plus or minus 1 over root 3.